Hello, this is Mr. Huber. In this lesson, we're going to look at radical functions and roots that are not square roots. That's why we call it a radical sign, not necessarily a square root sign, because there's other roots other than a square root. If you recall how we know what a square root of a number is, we see here 5 squared is 25. Right? 5 squared is 25. So 5 is the square root of 25. Right? We would write that out as the square root of 25 equals 5. Okay. 5 to the third power is 125. That's 5 cubed is 125. That's 5 times itself 3 times. 5 times 5 is 25, times 5 again is 125. So 5 is the cube root of 125. How we can write something like that out is, this is the radical sign, and we put a 3 here. That's a cube root. That's why we don't call this a square root sign. It's a radical sign, and in this case it's a third root. Here we don't have to write a 2. If we just see this radical sign, it's understood to be a square root, that there's a 2 there. So here the cube root of 125 would be 5. And then the fourth root of 625, that'd be 5 times itself 4 times, 5 to the 4th power. And that goes on. We can continue going. That works with different numbers, right? 3 times itself 4 times, or whatever other cube roots or fourth roots. Or you can take the 18th root of something, okay? We're going to work mostly with cube roots, fourth roots, some of those type of things. We'll see some examples down here below where we can use that. So this first guided practice example says to find the real square roots of 0.64. So that means we're trying to find the square root of 0.64. We need to find something times itself that gives us 0.64. So let's forget the decimals there. 64, the square root of 64 would be 8. So now we need to figure out there's a decimal point in there somewhere. So the square root of 0.64 would be 0.8. If you want to check it, you could do 0.8 times 0.8. 8 times 8 is 64, and we have 2 numbers in front of the decimals in our problem, so it would be 0.64. Okay? And we want to be careful here as well when we take the square root like that to indicate it's a plus or minus 0.8. Because negative 0.8 times negative 0.8 also gives a positive 0.64. So you take the square root of a number, you can get the positive or negative value of that number. All right? And if we look at some other examples as we continue down here, okay, let's say what the real square root of 9 over 121 is. When you have a square root of a fraction, so if we're going to square root this whole fraction, that's the same as the square root of 9 over the square root of 121. So the square root of 9 is 3, and the square root of 121 is 11, and then we'd have the plus or minus there. So plus or minus 3 over 11. So keep that in mind. When you have a fraction that you're taking the square root of, that's the same as square root in the numerator and denominator separately, if that helps to simplify it as it does in this case. And now we want to find the real root of the cube root of negative 27. Cube root of negative 27. So we need to find something times itself 3 times that gives us 27. So we're trying to see some number to the third power gives us negative 27. Okay. 3 times 3 is 9, times 3 again is 27. So this would be negative 3, because negative 3 times negative 3 would be positive 9, times negative 3 again would be negative 27. Okay. If we had changed that to the cube root of positive 27, it would be a positive 3. So we want to be careful. In a cube root, we don't have the plus or minus. It's either one or the other. Okay, in a square root, a negative times a negative still can give us a positive. So up here, if we did a negative 3 over 11 times itself, that would give us still positive 9 over 121. But here, negative 3 to the third would give us negative 27. 3 to the third would give us a positive 27. So you pay attention for that when it's an odd root that we're finding. Okay, or if it's an even root, that's where we have the plus or minus there. Okay, so next question says find the real fourth roots. So fourth roots, that's an even root. So that's where we're going to have our plus or minus of 16. So we're going to find the fourth roots of 16. So fourth root of 16. We need something times itself 4 times. It gives us 16. That'd be 2. 2 times 2 is 4, times 2 is 8, times 2 again is 16. And here we'd have a plus or minus. So plus or minus 2 would be the fourth root of 16. And now we have a square root of a negative 25. You want to keep in mind of something we learned about square rooting negatives recently, and that's that we can, in fact, square root a negative. Here, if it says a real root, though, we can't. Okay? So there's no real root of negative 20, square root of negative 25. There would be an imaginary, but not a real root, so none. Okay? And now we have the real fourth roots of negative 81. The real fourth roots of negative 81, so fourth root of negative 81, again, that'd be none, because we don't have a real number times itself 4 times, it gives us negative 81. We'd have to have a negative in there with an imaginary root, so just be careful of that when you're taking even roots of negative numbers. Square root, that's an even number. Fourth root, an even number. We come up here, we could take the cube root of a negative. Okay? And if it didn't say real roots, we could do this problem. So let's just talk about that here, because we've seen something like that. If we have the square root of negative 25, and it doesn't specify real roots, this would be 5i. Because 5 times 5 is a 25, and then the square root of the negative 1 is I. So remember, we can get imaginary roots, but not real roots of the square root of negative 25. All right. If we look here, before we see some other radicals to simplify, a flag that you see there is the only country's flag that is not a quadrilateral. Okay? This is a country in Asia. You may have heard of it. It's not a big country. It is bordered by 2 relatively big countries, okay? China and India. It is Nepal. The national flag of Nepal, the only country whose national flag is not a rectangle. All right. Now let's look at some more simplifying radicals, and we have some exponents variables in here with exponents to deal with as well. So first thing here, we take the square root of 49x to the 8th. So let's talk about the square root of the 49 part. That's going to be 7. Okay? The square root of 49 is 7. Then let's talk about the square root of x to the 8th. Okay? What we want to do is see how many times will this root divide into the 8. Because we want to see how many pairs of 8s, right? We need a pair of numbers. A pair of 7. 7 times 7 gives us 49. We want to find how many pairs there are here. So how many pairs are there in x to the 8th? There are 4 pairs of x's. Okay? This would be like saying x squared, x squared, x squared, and x squared. If we multiplied all of this together, we get x to the 8th. So there's 4 pairs of x's, x to the 4th. Okay? The square root of x to the 8th is x to the 4th. Again, really we want to see how many times can we divide 2 into 8. It can divide in there 4 times. So our answer for this would be 7x to the 4th. Again, if you multiply 7x to the 4th times itself, right, that's what a square root is, what number times itself. So 7x to the 4th times itself will give us 49x to the 8th. The next one's a cube root. So we need to find numbers that multiply themselves 3 times to give us 8. And then we're going to see how many times does this root go into the exponent here. So 2 times itself 3 times gives us 8. And 3 goes into 15 5 times. So what that's going to mean for our answer is this would be equals 2y to the 5th. 2y to the 5th. Because 2 times itself 3 times gives us the 8. And there are 5 sets of 3 y's that go into this. So how many times does 3 go into 15? It goes in 5 times. Okay. In number 9, we're going to see something a little different when we deal with the variable. First part, let's do the 243. So this is a 5th root. A 5th root of 243. We need something times itself 5 times. And you might need some guess and check to go on here. You might go, well, what could it be? Since this ends in an odd number, it's not going to be 2 or 4 or 6. This can't be an even number that when you multiply is going to give you an odd number at the end, right? I don't care how many times you multiply 2 by itself, you're not going to end in a 3. Or how many times you multiply 4 by itself, it's not going to end in a 3. So you could take some guess and check. You might try, what's 3 times itself 5 times? Or 5 times itself so many times is going to end in a 5. So you can narrow it down and make a decent educated guess. And let's try a 3, and it is in fact 3. 3 to the 5th power, 3 times itself 5 times is 243. So this would be 3. The 243, the fifth root of 243 is 3. And then we want to see how many times does 5 go into 13. It's going to go in there 2 times. It doesn't go in evenly, though, so we're going to have to talk about that. So we're going to have m squared, and then it's still going to be the fifth root of m to the third. Okay? When the 5 divides into 13 2 times, just like here, 3 goes into 15 5 times, 2 goes into 8 4 times, 5 goes into 13 2 times, but there's a remainder there of 3. So there's 3 m's remaining inside the root. The remainder is how many of those variables are remaining inside that fifth root. Okay? And be careful while you're writing this so we make sure we're getting m is the, to the second power, this fifth root, there's a third. So just careful how you're writing it out. You're indicating what things are exponents, roots, and different things like that. Okay? And again, make sure you understand what a root is. A radical, okay, radical here, to some root, that's how many times something needs to multiply by itself to get outside of that radical sign. All right? We'll be seeing some more examples of these and working with radicals and some different things going forward. We want to make sure we know how to simplify them. Again, this is called simplifying the radical expression.